Hello, I'm Shirly, coming from Partisia Blockchain Foundation, and I've been building out blockchain ecosystems past 5 years, and in the overall space last 7-8 years. And today talking why privacy technologies are needed and crucial in the growing trend of GDPR and data protection when it comes to web3 based solutions. So as we all know, web3 and public blockchains are extremely transparent, they're traceable, and the nodes are all replicating the data. And we're not talking about the regulatory uncompliant chains like Zcash, Monero, which are fully anonymous, but about infrastructures which are actually able to facilitate real-world solutions. So, but we have problem also in the public space. So. All the nodes, as they're running and replicating data, they're also being transparent for the data. And that doesn't fly when we're talking about supply chain systems or personal and confidential identity credentials. So, and fully anonymous systems, at the same time, infrastructures are also not creating trust. So how do we solve that issue? We do have, after the GDPR was enforced, many other jurisdictions in the world started developing similar data protection laws. We have BIPL in China, TPDPA in India, BIPA in South Korea, APPI in Japan, and in Canada, California, and Brazil have adopted similar data protection laws. But the fact is that the whole world is right now preparing for the privacy and data protection regulations, and it's coming, and it will be universally adopted in the whole world. So, as I mentioned, the current blockchain space that is extremely transparent can't facilitate all kinds of enterprise solutions, or when it comes to our identity and verifiable credentials. And the more these solutions are moving towards Web3 space, or if we want to get them adopted, we need some kind of infrastructure that is able to facilitate jurisdiction management and to ensure that all the data that these applications are handling and processing remain in fixed and limited local regions and jurisdictions to be able to comply with all these data regulations and laws. So currently there is no solution out there besides what's Partisia building. We have been building out decentralized solutions since 2008, and we launched the mainnet 2022. The token launch was just recently, end of March, and we have built an infrastructure which is able to facilitate real-world solutions. Here is our team. One of our co-founders is Ivan Damgaard that invented the Merkle-Damgaard hash function and SHA-1, SHA-2 algorithm, which is the base algorithm of Bitcoin mining. We have PhD in economics, Kurt Nielsen, that is specialized in applied game theory, and I will come to that a bit later. We have also considered certain economical incentives in our ecosystem to be long-term sustainable. We have Brian Gallagher, that is one of our co-founders as well. He has 12 different patents in US for blockchain applications. And also, this team is first to commercialize ever privacy computation and multi-party computation. The first researchers stem from early 80s, and now it's backed by 35 years of research and development and 61 commercial applications. So the team has been building out decentralized solutions for NGOs, governments since 2008, and we launched the foundation to drive the Web3 adoption, 2018. And something that we solve is the extended blockchain trilemma. So we have added privacy and interoperability to the mix. So how we solve the scalability is an infrastructural consideration through sharding. We'll come to the details a bit further. But also, if a traditional blockchain trilemma consists of scalability, security, and decentralization, then it's extremely important to consider interoperability and privacy in the mix to actually facilitate real-world solutions. So, First of all, how we solve privacy. So zero-knowledge proofs, which you might have heard of, are a great first step towards privacy, but they have certain limitations. So what we have used for the privacy solution is multi-party computation, which mainly is used in the industry for private key management and distribution by custodians and wallet providers. But we have developed a general-purpose MPC, privacy computation model, which has been optimized down to super low-cost, low-code solution, and we have united it together with layer 1 public blockchain. So the main difference with ZK proofs is it's not scalable. So you're able to use only one user input and one user data, and you can only have binary output, an outcome, either yes or no. You can verify if you're above a certain age, if you're vaccinated, but that's it. So if we're dealing with hundreds or thousands of different data inputs and users, we need a more scalable solution, and this is what MPC solves. How we solve interoperability. So we have integrated into our architecture an interoperability bridge, which facilitates all external assets to be paid on our chain. So when in other chains, it's a zero-sum game. All the blockchains out there are claiming they're the fastest, they're the most low cost, and they invite the developers to build on their chain in their siloed ecosystem, forcing them to acquire their token or asset in order to process transactions. And we have worked out on a collaborative solution where developers can bring any type of coin. So the interoperability bridge is called BYOC, Bring Your Own Coin Bridge, as well as users. They can pay transaction fees in each external asset, and they can be sure that it never fluctuates in the price. If the network reaches capacity, the transaction fees are still at fixed price, considered in dollar value, then cents. So another interoperability advantage using our ecosystem is you're opening up a customer base to all types of coin holders and token holders. When it comes to gaming, for example, they're able to pay for skins or in-game assets in all kinds of external coins. And whereas in other chains, the user must acquire your token first in order to facilitate any transactions or purchases. And this is limiting down the use case and collaborative approach, because we believe that blockchain should be like infrastructure, like internet used to be, where you can, like internet is nowadays still as well, where you can plug in different internet service providers, and it's not limiting down to ecosystem-specific applications. So current space is very siloed and limiting the entry. Another interoperability advantage that we offer to other protocols and ecosystems and applications built on other chains is MPC as a service. So in essence, we have 3 layers. Layer 0 for the interoperability, layer 1 for normal public transactions, and layer 2 for privacy computation. So a use case built on Ethereum or BNB or Polygon doesn't have to transfer over their application. They can only switch the smart contract to the necessary customized privacy computation using our L2. We have the biggest MPC cluster in the world, and the output will be transferred back to their native layer 1. They can pay for it using their own native assets, so we don't force them to come over to our ecosystem. So currently we're supporting these ecosystems. We're adding Bitcoin, we're adding Solana, we're adding more layer 1s. So how do we solve the scalability part? We have adopted something called true sharding, which dates back to the very original definition of sharding from early 90s, how databases have been scaled. So the current sharding model is still posing bottlenecks in the Ethereum ecosystem, but we have created a parallel scalability. Each shard operates as an independent blockchain. So in traditional sharding model in the blockchain space right now, blocks are limited down to the epoch times. They're being vertically added on top of the chain. In our case, each shard, currently there are 4 shards, operates as an independent chain, and they're communicating between each other via a proprietary messaging protocol. And it's not only increasing the scalability, in theory, we can facilitate infinite scalability, because you can go up to 1,000 different shards. One shard processes 1,000 transactions. It also creates new business models in DeFi, like different liquidity pools being operatable in each different shard. And that also brings down the transaction finality sub-second, so 0.3 seconds, which is extremely important, facilitating real-world applications. So what are the opportunities? Perhaps you have heard of DePIN, Decentralized Physical Infrastructure Network, which is raising or increasingly more popular. So all our health record devices, like Apple Watch or GPS geolocation tracking devices, finishing up with supply chain systems in the enterprises, or even refrigerator content nowadays is being monitored. These are they're processing and they're storing data. And what DePIN does is enables users that provide that data to be rewarded. So it's a peer-to-peer system where users get paid for providing the data. But DePIN requires certain architectural infrastructure, like storage of the data, which in ideal world should be decentralized, storing on IBF or Filecoin, and also the scalability of the chain, because we're basically using DePIN, we're providing hundreds or thousands or 10,000 different data sets each second. And another architectural consideration is the privacy of the data. Because we need to make sure the data doesn't get outside a certain jurisdiction, especially if it comes to health records or identity, as well as, especially in the supply chain system. So we need a technology that keeps the data confidential, encrypted, but you're still able to put it into use, and you're able to use and sell the use of your data. So where else it's crucial? For example, we're the only network that provides interoperability between private and public network. So if we speak about big, large enterprises and corporates that have certain very confidential supply chain or internal intranet on their private network, they're able to still provide access to public using a public network. So certain data needs to be confidential and computed on. And at the same time, you can do a hybrid model where you accept patient data or individuals' data using Partisia blockchain multi-party computation. So that really facilitates real-world business solutions, because they would never do full-fledged solution on Ethereum or Solana or any other public blockchain out there. So we're also working on a decentralizing digital ID for the Swiss government in collaboration with 2 other universities. Swiss government has committed to decentralize the ID, giving users and citizens back the control and governance over their data. And it's also important that there is a privacy feature in place, which keeps the data confidential and it wouldn't leak. We also have different healthcare and pharma solutions which require certain elements of privacy and confidentiality, but from the patient and end user and beneficiary side, there needs to be transparency, and this is where Partisia can offer a hybrid solution. We also built a payment solution for Red Cross, as in the crisis zones, the beneficiaries are already in a vulnerable situation, and in donations and cash and voucher assistance mostly ends up in wrong hands. So there was a payment solution created using stablecoins, where for Red Cross, they have full traceability and transparency how these funds are being deployed, but the end user would be protected at all costs and kept private. So we have started off with a lot of enterprise and governmental and NGO solutions, but now we're gearing up more on the web3 side of the things. But here are some other use cases where MPC is crucial, like AI training. Currently, AI is only dependent on the public data. So how to train an AI model using also private confidential data or even keep the AI model itself private. This is where MPC solves the problem. So there are many use cases which cannot be facilitated without the use of multi-party computation. This is our current ecosystem, which we are growing eagerly every day. And I mentioned some of these projects from the enterprise and government side, but we are gearing up to a DeFi and real-world asset tokenization. So we did launch or announced recently the launch of our 100 million grant program. So we're waiting for developers and projects to reach out if they're interested, bringing their solution or part of their solution if it's currently on another chain where they are in need of the privacy computation. It's a Rust-based programming language. But we are able to work with all the other protocols out there as well. And I would like to ask for, do a question round. Does anyone have questions?